400 nautical miles north of the Arctic Circle, a 90-meter steel vessel goes through the Barents Sea, minus 1.8 degrees water. The numbers define the reality. 60 kilometers of main line, 30,000 hooks, 1,000 meters of working depth. This is not fishing. This is industrial harvesting at the edge of the world's most hostile environment. The target is Hippoglossus hippoglossus, Atlantic halibut, specimens living in absolute darkness where pressure exceeds 100 atmospheres. The vessel's reinforced hull crushes ice blocks weighing 3 tons, with hydraulic systems maintaining immense pressure. Every component is engineered to extract protein from the abyss, while the crew operates a floating factory weeks away from the nearest harbor. A single equipment failure here transforms precision engineering into a survival scenario. The hydraulic winch systems pulling tons from the sea floor, the moon pool, a deliberate breach in the hull, where Arctic water churns just feet below the deck. One miscalculation, one seal failure, and a multi-million-dollar operation becomes a logistics nightmare. This is the reality of the Arctic arsenal, where every system must function perfectly, because there is no room for error at the bottom of the world. Inside the climate-controlled baiting room, automation assumes control. The Mustad autoline system processes semi-frozen mackerel at 3 hooks per second. The mathematics are critical. Each unbaited hook represents a financial loss measured in tons of missed opportunity. The bait protocol is specific. High-fat Atlantic mackerel, oil content verified at 18% minimum. Halibut hunt by scent in absolute darkness. The oilier the bait, the stronger the chemical trail. But there is a precision tolerance that separates success from failure. 2 millimeters. The difference between optimal bait thickness and operational disaster. Too thin and the hooks strip clean. Too thick and scent dispersal weakens. Field operators monitor every slice.
Bait thickness holding steady, oil content confirmed.
The engineering challenge intensifies with volume. 30,000 hooks demand precision manufacturing. The slicing mechanisms must maintain consistent cuts while processing 9 tons of mackerel. Temperature becomes critical. The bait must remain at -2 degrees Celsius. Any warmer and the slice integrity fails. In this industrial equation, there is no margin for approximation. Every variable is controlled. The difference between a successful set and empty hooks lies in seconds of precision timing. The factory floor tolerates no weakness. On the bridge, the captain studies 3-dimensional sonar data. The display reveals what lies 1,200 meters below. Underwater canyon systems carved into the continental shelf. The target zone appears as a digital cliff face. This is geology as hunting ground. Atlantic halibut position themselves along these ledges in ambush formation. The sonar penetrates sediment layers, revealing bottom composition indicating different densities. The deployment sequence begins at the stern. 60 kilometers of mainline engineered with a polyethylene core and high tensile steel wire. GPS coordinates are logged every 500 meters.
GPS lock confirmed. Coordinates locked. Descent rate optimal.
Here, precision becomes survival. The critical calculation, soak time. Too short, and the scent trails haven't dispersed. Too long, and scavengers arrive. Hagfish can reduce a prize catch to skeletal remains in hours. The window of opportunity is exactly 6 hours, calculated using current speed and water temperature. The crew monitors real-time variables to prevent gear loss.
Current holding steady. Scent corridor optimal.
The line settles, draping across underwater cliffs like a steel spiderweb. 30,000 hooks now wait in absolute darkness. The clock begins counting. In 6 hours, the real test begins. Six hours later, the hydraulic winch systems engage. The massive steel drums begin retrieving 60 kilometers of mainline. The physics are unforgiving. Each hook potentially carries 150 kilograms of halibut. Pure muscle evolved in 2-degree water. Through the moon pool, the mainline emerges from darkness. Water temperature sensors register the transition. Each meter retrieved represents precise mechanical coordination.
Tension indicators holding steady. Hydraulic pressure stable.
But automation ends the moment biology begins. When a giant halibut breaks the surface, crew members wielding steel gaffs must manually secure thrashing specimens. The engineering challenge intensifies. Hydraulic winches strain against massive loads. Tension indicators spike as cables sing under pressure.
Large fish on the line. Gaff crew to positions.
The creatures emerging from the deep represent evolutionary perfection. Bodies compressed by 100 atmospheres of pressure. When they thrash, the force generated can shatter bones. 3-man gaff teams coordinate with surgical precision. The lead gaffman targets the head, avoiding the powerful tail. Each fish represents a test of engineering versus biology. Hydraulic systems fighting deep water adaptation. The steel deck determines whether the crew controls the catch or the catch controls them. This is the moment where industrial precision meets biological force. The moment each halibut strikes the processing deck, the clock begins. 20 minutes. The cellular window between a premium specimen and worthless protein. The processing deck becomes an operating theatre. First priority, exsanguination. The fish must bleed while the heart still pumps. Professional cutters work with scalpel precision. Wait 30 seconds too long and lactic acid floods the muscle tissue.
Heart rate detected. Beginning exsanguination protocol.
Internal temperature must remain below 4 degrees Celsius. Deck-mounted cooling systems create localized climate zones. The cutters move efficiently. Organs removed in 12 seconds. Visceral cavity cleaned.
Organ removal complete. Temperature holding steady.
The final phase, plate freezers. These are precision crystallization chambers. Halibut fillets are sandwiched between aluminium plates, applying hydraulic pressure, while liquid refrigerant drops ambient temperature to -40 Celsius. The physics of rapid freezing determines cellular preservation. Ice crystals forming too slowly puncture cell walls, destroying texture.
Plate pressure steady. Crystallization proceeding on schedule.
Field operators monitor the process. The target: complete cellular water crystallization within 4 minutes. Any longer, protein structure degrades. The technology locks cellular structure so effectively that when these giants thaw in Tokyo months later, the texture remains indistinguishable from fresh caught. This is industrial precision applied to biological preservation. After 21 days at sea, the vessel returns to port, carrying 180 tons of frozen assets. The moment the ship docks, a precision logistics machine activates. Hydraulic cranes lift palletized blocks of Arctic halibut. The cold chain documentation begins. Temperature logs recorded every 15 minutes during the voyage.
Cargo hold temperature confirmed -38 Celsius. Export documentation verified.
These frozen blocks must travel 8,000 kilometers to reach Tokyo's Toyosu market. Refrigerated containers maintain the cold chain across international shipping routes. The logistics challenge intensifies with distance. Container ships crossing the North Pacific encounter extreme temperature variations. Refrigeration units must compensate continuously.
Container loading complete. Refrigeration unit operational.
"72 hours later, at Toyosu Market, buyers assess quality. Texture analysis reveals whether ice crystallization occurred within the critical window. Premium grades command top market value. The difference is determined by cellular analysis, conducted 8,000 kilometers from where the fish lived.
Quality assessment complete. Grade A classification confirmed.
The supply chain extends beyond Tokyo. Refrigerated trucks transport premium cuts to high-end restaurants. Each shipment is tracked by GPS and temperature sensors. What appears as a simple white fillet represents the coordination of GPS navigation, hydraulic engineering, and cellular biology. Arctic water temperatures and pressure calculations all converged to deliver protein harvested from the planet's most remote hunting grounds. The floating factory has delivered its cargo.
Vessel departing port. Course set for Barents Sea.
The steel hull cuts through harbour waters, heading back toward the white horizon, where 30,000 hooks will descend into absolute darkness. The machinery never stops. The giants of the deep continue their ancient patterns, unaware that above them, precision technology transforms their domain into humanity's most remote production floor. This is the frozen factory, where the abyss meets assembly line efficiency, and where every component serves a single purpose, transforming the ocean's giants into the world's premium protein. The ship fades into Arctic fog. The cycle begins anew.